advancement that has been happening during the last 1 decade or so. So we have research in various fronts. Professor Eddie already has given you some pointers to some of the high level discussion he has made on various topics. So I thought that I should actually show you some of the interesting research dimensions in AI and natural language processing. Typically, I'll not talk much about sentiment, but in sentiment analysis, one important aspect is the aspect-based sentiment analysis. I'll talk about that. And this slides, if you see that this is the entire territory of artificial intelligence, and these core components, particularly the search, knowledge representation, reasoning, machine learning, these are all the core components of any AI systems. Now, whether the application is related to a computer vision or natural language processing, or you are solving a problem of robotics or planning problem, or even the expert system problem, the idea is that we have to actually have a kind of core components as has been displayed in this particular slides in this inner circle, that without search, robust search technique, you really cannot build a AI system. And this search is not only the searches like breadth first search, depth first search, or traditional other search algorithms that most of the time probably have used, but it needs some additional informations about the destinations in the form of the heuristics. So you need the technique like A-star search, for example. If the search space is very huge, then you need other local search algorithm like hill climbing, simulated annealing, then genetic algorithms. So these are all the algorithms that have been extensively used for developing the systems of AI. Then knowledge representation reasoning, which is the classical way of doing artificial intelligence. Then we have the machine learning that mostly we are discussing these days. And machine learning concept actually, in most of the cases, you see nowadays, the systems that are built on, they are predominantly built on the machine learning concepts. And probably we hardly use that knowledge representation and reasoning technique these days. But still there are a lot of, you can say that, okay, interesting things in knowledge representation and reasoning mechanisms. And the neurosymbolic AI that Professor Eric was talking about is basically the combinations of these two paradigms, like knowledge-based AI plus machine learning oriented AI. Now, in this discussion, we'll mainly talk about machine learning and NLP. But before we go, you should see this trinity of natural language processing, where you can see that on the left side, there are various problems of natural language processing, like morphology, processing of the sentences that actually has to deal with the structure of the word. Then in the, if you go a bit upward, you have part of speech tagging, which is the syntactic processing of the input. Then once you know the grammatical categories, okay, of the words, you can group them together, which is the problem of chunking or the phrase identifications. Once you have identified the phrases, then you can draw the full parse tree, the set of grammatical rules that are actually applied on the input sentence, generate a sentence structures. We have semantics then that deals with the meaning of the words, right? And after semantics, we have the discourses, coreferences, pragmatics. Now, if you see these different, the direction in which it is flowing from the lower level to the upper level, you can consider that the complexity of processing increases. So what we mean by this is that if you are dealing with the problem of parsing, so the problem of parsing requires is harder compared to the chunking or POS tagging or the morphology processing. If you are doing semantics, so semantics is harder than any of these lower level tasks. So ideally, as you go in the upward direction, the complexity of processing in the NLP layers actually increases. Now also, another important aspect while you deal with the natural language is the level of ambiguity. So at every layers of NLP processing, being it is a morphology or a POS tagging or a chunking or a parsing or semantics or discourse, it is the ambiguity that makes the tasks more harder. If you are doing POS tagging, whether the word book, BWK book, is a noun or a verb, that depends on the context. That is also a kind of ambiguity. If you are doing a parsing, now parsing also has varieties of ambiguities. For example, if you say that I saw the boy on the hill with the telescope. I saw a boy on the hill with the telescope. Now the question is that who has the telescope? Are you seeing the boy with your own telescope, or the boy, you are seeing a boy and the boy himself has the telescope? So this kind of notions will complicate the processing. Then semantics obviously is the issue of when you deal with assigning a particular meaning to the word. So there can be a lot of ambiguous cases. And the semantics, particularly whether the word interest, for example, is a related to the financial domain, or the interest, maybe the interest in a particular subject. So that actually is the issue of semantics. Then the discourse comes, co-reference comes. And as you can see that any problem, let's say I am solving a problem of sentiment analysis, machine translation, question answering, or summarizations, natural language generation. So these tasks requires all these lower level processing. It may require semantics, it may require parsing, it may require chunking, POS tagging, morphology, etc. Now, if you do a very traditional way of doing natural language processing, you will see that if your lower level informations or lower level processing are erroneous, that means if POS tagging is not highly accurate, chunking is not highly accurate, parsing is not robust, then this actually will propagate the errors to the higher level. So that means if there are a lot of parsing problems, and if you are doing a semantics, then the problem of parsing will actually affect the performance of the semantic analysis. So we have to ensure that all the lower level processing should be as much perfect as possible. Now on the right side, you see that the whole NLP we can represent as this three-dimensional representation, where on one side you have different languages. One side you have the problems of these problems like morphology, POS tagging, semantics, discourse, co-reference, etc. And the other side you have different algorithms like the probabilistic machine learning algorithm, like hidden Markov model, like maximum entropy Markov model, like conditional random field, like recurrent neural network. So these kind of algorithms we make use of. So what does it mean? The NLP we are representing as a kind of triplet, which has three different components. One component is, sorry, denoting the uh, specific problem. Let's say I want to do the part of speech tagging for Hindi. Now you have to decide that which of these algorithms to be chosen for part of speech tagging in Hindi. Whether hidden Markov model is better, whether maximum entropy Markov model, which is whether conditional random field, whether a recurrent neural network. What kind of algorithm is to be chosen for doing the part of speech tagging for Hindi? Now, if you want to do the part of speech tagging for English, whether the same algorithm is useful, that we have to decide, or we have to choose a separate algorithms. This is how the NLP can be represented as a kind of triplet, okay, where you have three different components. Now, if you look into our situation, that Indian situation, India obviously, all of you know that is a multilingual country with a lot of linguistic diversity. And the languages are covered mostly from the major streams like Indo-European family, we have Dravidian family language, Austroasiatic family language, Sino-Tibetan family of languages. And many of these languages are spoken by considerably large number of populations like Hindi, Bangla, Marathi, then Malayalam, for example. So they are highly spoken languages, and the number of speakers is really significant in numbers. But if you see that officially, although there are 22 languages, these are some of the statistics that shows that there are 122 major languages, almost 1600 regional languages, and many scripts, dialects, many language, 30 languages almost are spoken by 1 million native speakers. 122 are spoken by more than 10,000 people. But unfortunately, only 20% can understand the global language if you see English, and 80% cannot. So now what is the way out? So the way out is that you have to build very strong AI model enabled with a lot of natural language understanding and machine learning that can deal with these language diversities. Okay. Also, on the other hand, if you see that social media, review, websites, etc., in the internet, the gradually the contents in Indian languages is also increasing, and a significant reason why comfortable break this digital divide. The Digital India movement of the government of India, there one of the major components, if you can build a good NLP systems, the natural language processing systems that can bridge the language barrier, that will be extremely beneficiary to the common citizens. So you have to, this is the reason why in a multilingual country, the natural language processing plays a very important role. Okay. Now you see that there has been a lot of advancement. Professor Eric has already told you that there has been a lot of transition has happened over the period of years. If you see, it is 1950s Turing test, which was actually a kind of question answering test by Alan Turing. He posed actually a set of questions to a machine and a human. And then he analyzed the set of responses produced by the human and the machine to understand the shortcomings of any computer systems compared to the human. That was the famous Turing test. He came up with a lot of observations that where a machine fails compared to the human, what are the challenges before it? And since that, if you see the progress that how AI field has progressed over a period of time, there has been a lot of very practically, you can say that practical system has emerged. Many industries have commercialized many sophisticated models like Google's search engine, Alexa, Google's machine translation systems, several systems for healthcare, mental health, the misinformation, fake news, hate speech monitoring. So people have been, industries have been working on this. Now you know that even the DeepSeek most recently has been introduced in the family of GPT-4, ChatGPT, then the plenty of large language models that have come up. Now, historically, if you see that earlier, most of the learning algorithms that we used is based on the probability and statistics. Like hidden Markov model has been tremendously successful for doing a lot of sequence leveling tasks. For example, part of speech tagging, chunk leveling, then parsing. The hidden Markov model has been used. Then maximum entropy was introduced to actually address some of the issues that hidden Markov model faces. Then conditional random field is another variations of this particular family, which is very powerful in doing the sequence leveling task. Then we have other families like support vector machine, logistic regression, etc. So you'll see that in AI, natural language processing, these kind of techniques have been used. But all such techniques, the classical machine learning, what it needs is that it actually needs the handcrafting of the features. And this handcrafting of the features, one second, I think if there is an issue. Yeah. So handcrafting of the features is actually is the main, you can say that challenging part of doing any classical machine learning. It actually have to do identify a lot of features. If you are solving a problem, any AI problem, let's say spam filtering you are doing, and then spam filter whether incoming messages in your email is a spam or a ham. Ham means I'm saying the genuine one. How to build this kind of spam filters? You need to identify that what are the features of a spam email, what are the features of a genuine email. So if you suddenly get an email with a lot of monetary transactions, then you suspect that probably this is not of genuine in nature. So these kind of features as an expert you have to identify. And this is known as the handcrafting of the features, which requires your understanding about that particular problem, your understanding about the data that you are using very well. So you have more control on the algorithms. You have more control on the data because you know the problem very well. But one issue with this is the time consuming because you have to come up with the features, number of features may be large, you have to reduce the dimension. So those are the issues that you can get with the classical machine learning or the shallow machine learning algorithms. Now, as a remedy, then from 2010 onwards, particularly deep learning models were very popular for solving various problems. And one advantage of deep learning is that you don't require any kind of manual feature engineering. You don't have to know that what are the features of identifying an spam email. What are the features of a kind of genuine email? You don't have to worry about this. If you have plenty of such emails which are already known to you as genuine and spam, if you have a good representation technique that already you have some ideas in the form of what could be a globe, part, etc. You have a good representation mechanisms, lot of data. You feed those informations into a sophisticated neural network, probably you will get a good output. Now, if you ask yourself that what is happening inside the model, why you are getting good outputs, that is a different question. You need more control on that. If you want to have a more control on it, then you have to understand what is happening inside. Why suddenly which features actually were triggered for a particular output. Those are the part of interpretability, explainability of the models. So this actually, you see that over a period of time, because of that reasons, there has been tremendous growth, and and now we are in the era of large language models, right? And that has completely changed the research directions. Now there can be various problems. For example, I'll show you that at IIT Patna we have a group on working extensively on AI, machine learning, natural language processing. And we have actually been doing various tasks like conversational systems is one that we have been investigating very deeply, like natural language understanding. Then if you are generating some responses. How can you make the response more empathetic? Then how can you make a dialogue system knowledge grounded? So a simple example, if you ask that why is 2nd October important in India? Now, maybe from the dialogue, you may not get this information directly. You need some kind of global knowledge, the common sense knowledge that in India, 2nd October is important because the birth anniversary of Mahatma Gandhi. So you have to actually ground your conversations on that external knowledge, on the common sense knowledge. Then personalization is another factor because when you build a conversational AI agent, it depends on the personality of the speakers. Okay, so if the model, the bot has understands very easily that who the person is, with whom the bot is talking to, what is the personality of that particular bot, then I think that plays a very important role. So, for example, if I like the sports, and when start interacting with the bot understands uh, at the beginning of the conversations, after few turns, that I am a sports lover. So whether the bot is able to talk to you or suggest you or engage you in a conversation related to sports. But if you are a movie loving person and if you started talking, chatting with the bot, whether the bot is able to understand that you love movie and after a few turns it starts conversing with you in related to the movie. That is how the personalization happens. Okay. So then we have another very big disciplines called the machine translations, that where you can translate from one language to the other language, which is one of the very hard problem of natural language processing. So in computer science term, you can consider it as a kind of NP-complete problem. So if you look into the history of machine translations, particularly starting from the Second World War, the Western world wanted to translate all the Soviet literatures, Soviet documents written in Russian language into English because it was their necessity. They tried to they started investing a lot of funding for building the machine translation system, but soon there was a lot of pessimism uh, because of the challenges, the ambiguity at different levels, and the peculiarity of the different domains. It was thought of that machine translation is not a solvable problem. So the researchers stopped this, working on this translation problem. Okay. So there has been a lot of kind of drop of machine translation, particularly the people of AI thought that this is not at all solvable. So luckily, then again it started because it was the necessity. If you want to bridge the gap of languages, the translation is a very important technology. IBM research particularly came up with commercialization, successful commercialization of basic translation system. And they came up with IBM 1, IBM 2, IBM 3, IBM 4, 5 different models, which are based on the probabilistic framework. Then Google also came up with the phrase-based machine translation systems during 90s, 1995 to 2000 during this period of time. Then if you see that after 2011, 13 onwards, particularly 16 onwards, now the sequence to sequence model, particularly the model which are extremely powerful for doing these translations. Okay. Then we have हेलो हाँ बोलिए हाँ तो मुंह पे दे दीजिए एड्रेस तो लिखा हुआ है ना आपके पास हाँ B1 में ना हाँ B1501 दे दीजिए हाँ हाँ वही तो है B1 मतलब B1 हाँ B1 500 मैं नहीं हूँ घर में आप दे दीजिएगा ठीक हॉस्टल का नहीं, रेसिडेंशियल ब्लॉक है ये, रेसिडेंशियल ब्लॉक है, ठीक है। नहीं नहीं, रेसिडेंशियल मतलब जहाँ पर लोग रह रहे हैं ना अंदर में, उधर का है। हाँ। Sorry, yeah. So now sentiment emotion is another important areas where you can see that there has been a lot of works. Professor Eric has done a lot of things, a lot of research, particularly in the sentiment and emotion analysis. So, like coarse grain sentiment analysis is possible, fine grain sentiment analysis. Then, if there are more than one languages, so multilingual sentiment analysis. Now, if there are more than one modality, like along with the text, you also have the image, video, audio, etc. Then you actually have to deal with all such kind of informations. Now, this is very natural and this is very important, and that is known as the multimodal sentiment and emotion analysis. Then we have information extraction, like question answering is a very important domain. Extracting the events from the text is the event extraction. Then if something is fake, you have to detect that misinformation. Hate speech detection is another very important area because that actually causes problems in the society, misinformation causes in the society. So if you can detect the misinformation, if you can detect the hate speech well in advance, that actually helps to maintain the social fabrics. The novelty detection, that how AI can be used in scholarly communications, that is another thing. That huge amount of research paper is getting produced. If you see the big conferences like AAAI, for example, International Joint Conference on AI, ACL, EMNLP, or any very popular machine learning like NIPS or ICML, these kind of conferences. So the number of papers that people submit is huge in number. For example, AAAI gets almost 7,000 submissions. Now, how to manage this huge amount of submission? How to get the good reviewers to review the paper? Reviewers may not be mature in many cases, so they might have the disagreement. So how can you automatically identify that the reviewers are disagreement, are not in consensus? So what are their disagreement? What are the points that they are not agreeing? So this is also very crucial. So we have been doing how AI, NLP, machine learning can solve the problem of, let's say, scholarly document processing, particularly the identifying whether a research paper is novel or not, how the large language model can generate some new ideas, novel ideas. If there are multiple reviews written for a paper, what is the disagreement between them? How automatically you can write the meta review from the research papers. So this is one very interesting research directions that we are working on. Now, I'll show you very briefly that what is this conversational AI. Probably all of you know. As I mentioned, that the main idea of conversational AI is dates back to 1950s Turing test. The Alan Turing exactly had this kind of conversational AI systems. He posed a set of questions which were in natural language to a computer, and the responses that he obtained were compared to the human responses. Now, if you see that in the beginning, so the first commercial, you can say that successfully deployed, not commercial, successfully developed and deployed systems is the Elijah at MIT in 1960s. But that time, this conversational AI system was not was mainly uh, able to retrieve the responses from a predefined set of responses. So what do you mean by these? Hello? मैं आपको बोला ना, मैं नहीं हूँ, आप ऊपर जाइए ना, दे दीजिए ना GIAN Course में। हाँ हाँ, घर में है, आप दे दीजिए उठ के। हाँ, उठ के पास होगा, रिंग बजाइए, घर में जाके कॉलिंग बेल बजाइए, ठीक है। हाँ। So you see that today chatbot is not like that. So now we have to understand the deep language understanding is important. And today's conversational AI is not merely looking into choosing uh, one of the predefined responses, right? For example, movie booking, railway ticket booking if you are doing, or let's say from the list of songs, you are asking that Alexa that, okay, can you choose the set of song, one of the song, sad song, let's say, or let's say romantic song for one of the predefined set of songs. So these tasks are not very difficult because you already have the known answers and you just have to match with the known answers. So you can easily retrieve it. But for example, if you want to do a kind of counseling, okay, or let's say attracting the customers, for example, to negotiate with the customer, to persuade with the customers, or to have a kind of deal with the customers, okay, to sell your product, okay, as an agent, or let's say you are convincing a particular person to donate for the charity, okay. So then it is not likely that the conversation will be very dynamic, and the dynamically change based on the speakers, let's say different moods, for example, the emotions and different other factors, external factors. How your conversational system can adapt to this automatically? How can conversational system can understand that the speaker is in not a good mood, the speaker is in a pensive state, is in a happier mood? How the conversational system will understand all these very fine-grained, let's say the mental states of the speakers who is undergoing a lot of mental trauma. So this is what is today's chatbot, the next generation AI is looking for. And this is important because as a kind of one of the statistics that has already reached to this kind of huge market we have. Now, what do you mean by this very interesting chatbot? This is an example that you can understand that this person is saying that I finally got promoted today at work. Now, if the bot or your friend even says that why would anyone promote you, then probably you will not feel good, and this conversation will not continue for a long time because you will not be happy because your friend is not acknowledging the fact that you have really achieved something great. But on the other hand, if the bot says in this manner that congrats, that is great, then this person will feel better because the bot has understood that this person has achieved something, and because of that reason the congratulations has been given, and so the interaction between this person and the bot will continue. And that also happens in our day-to-day communication. Forget about the bot. In our society, in our day-to-day communications, let's say if your friend is also behaving in this manner for a long time, that your friend is not happy whenever you get a success, let's say. So over a period of time, you will realize that probably this relation may not continue for a long time, right? And then you discontinue, you disconnect with each others. If your friend is not on your side when you actually need his or her support, then also you'll see, and this happens quite often, then probably you'll also realize maybe there is a problem with the connections, right? And you lose the interest in getting connected to your friend. So now we are replacing a person, a human, with a machine, with a bot, which has the capability of understanding the human emotions, the human mood, the speaker's emotion, etc. But how can you build it? What are the models? What are the features? What are the ways to do that? That will be very interesting. Now, this is what we mean by the empathetic conversational AI. Then we have other things, let's say, in a conversation where it happens, the number of emotions is not only very fixed, the emotion can change. Like you can see here that it is amazing, I'm thrilled you got promoted. So here you have two emotions, surprise and joy. Okay. And their intensity is also mentioned. Let's say surprise is 0.3, joy is 0.9. And they have been talked in with two different intensity levels. Sometimes here the surprise is 0.3 in the scale of 0 to 1, joy is more. And this is very natural. In a conversation, the emotion can be multiples. And also the conversation, the emotion drifting is always possible. Emotion changes. So for example, ideally in a situation, let's say in a teaching profession, we have been there, we have been guiding many students. And if we assign a task to a particular student, and if the student is not delivering that for a long time, obviously the very first time when we met, we actually are very upset maybe with the student that you are not working, and then maybe you are, as a guide, we are very angry. Sometimes it's sad also because the student is not working. And then if you realize that the student was really having a problem, some health issues, some personal issues, some other issues maybe, then probably we understand that the reason behind non-performance, right? So gradually the emotion, which was very sad, anger, that will gradually change into maybe a surprise. If the health was very bad, then something has happened with the student, then you are surprised to know about that. And then later on during the conversation, you will see that your emotion will keep on changing. Now, how a bot will deal with such kind of changing emotions, right? Where there are multiple emotion drifting is possible. So that is the issue of uh, the empathetic conversational AI. And we have been doing a lot of research in this particular area. We had several students already graduated, and still few students are working on this particular front. And this is one of the work that we have done in AAAI 2021, that how can we build a models in AI agent that actually can handle more than one emotions, where the emotions with having different intensities. Those will be the challenges. So now if you want to build a very good systems, obviously you need to understand the sentiment. You need to, it should be knowledge grounded. You have to understand the intent, why it is being spoken. You have to understand the context, why something has happened. You have to understand the mood of the speakers to make it more aware and relatable. Okay. Now, another interesting dimension is that we have been doing is that can you make a bot to behave in a polite manner? It's a politeness, personalization. These are all the important factors. I'll also just give you the idea. I'll not go into much details, but we have already done quite a few publications starting from 2019. There are several publications where we have shown that how politeness can be incorporated into a chatbot or a conversational agent. Now I'll just show you that why it is important. The maintaining the politeness is important because this is an important factor in our day-to-day communication again, right? So any society, let's say the politeness, courteousness actually helps to maintain the relationship better. And in a business also, this is extremely important. In this particular work that we have done in HLT NACL 2019, it was actually about building a polite chatbot, okay, for the customer care setting. And customer care setting, the maintaining the politeness is very important. You want to, let's say, if your customer is suffering because of a particular service, and if the customer is reaching out to the agent and the customer care agent does not behave well with the customer who has been suffering with the service or the product, then as a end user, you will not feel good and you will prefer, you will try to find out an alternative to that, right? So that way it will be lost to the business. So for example, here you see that how can I help? This is the response of a traditional bot. And there was a context, I have not written the context. The context is that the person was suffering due to the internet problem, and then the person has reached out to the customer care, and the customer care is saying that how can I help? So this kind of response is very mechanical. But if the response is like this, that we are sorry to see you are having trouble, help has arrived. Now here you can see that these two statements is making the conversation more polite. And even as a customer, you had initially, you are facing the problem because of this polite behavior. You will not feel very bad. And you'll try to understand actually the problem that actually happened. Maybe some technical problem happened because of which the internet was not coming properly. But if the agent behaves with you in a polite manner, that actually will be very helpful for you, right? But how can you build a chatbot that incorporates such kind of behavior? So that is very important. There are plenty of other examples. I'm not going into details of that. This courteousness, consistency, specificity, all these actually will make the conversation more human-like and engaging. And these are all the next generations of AI technologies. Now, sentiment a bit, for example, if you go to the sentiment again is a huge discipline. And we have been doing also, we have addressing a lot of different problems in sentiment analysis. That if you do the sentiment at the very coarse grain level, coarse grain means I'm saying that you pass the document, you pass a review, and then you do the sentiment analysis. That is one thing. But if you want to do the fine grained sentiment analysis, let's say aspect level sentiment analysis, for example, a particular product can have different features. If you want to buy a laptop, then the screen of the laptop, then the battery of the laptop, then the video camera quality of the laptop. So all these are the important features. Now, with respect to these features, what the other reviewers have commented, maybe some reviewers have commented good about the camera, but they are not happy about the battery life of that particular. Then what will happen? Okay. So then languages also that coarse grain, fine grained. Then we have the languages like English, Hindi, French, etc. We have different domains like e-commerce, social media, financial domains. We have been doing a lot of techniques like feature engineering based, deep learning based, then feature engineering plus deep learning, then multitasking models. Okay. Uh, Feature engineering is the classical machine learning algorithm. Deep learning is the uh, mm, models you have already learned that it does not require the feature engineering part. How can you combine these two disciplines together? That also we have been doing. Then it has a lot of application in terms of e-commerce, obviously choosing a particular product over the others. In the security perspective is very important. For example, if you the languages that why security is important and emotion and sentiment can play an important role, because if you are actually talking something very negative about something in the social media, there can be a virtual crowd in the social media. If it actually talking very negative, okay, then against the government, that can pose a security threat to the law and order situations. So the extremely negative opinionated content, the government would like to know that who are the person who is writing this. So that way, it actually helps the security agencies to maintain the law and orders. Now, suicide ideation is another one, that mental illness, mental health, suicide tendencies because of extreme negativity. So we have been doing some research on that, and our PhD students have already graduated who has extensively worked on the suicide ideation, mental health. Sarcasm, humor is another problem, very interesting problem of sentiment analysis. Now, as I mentioned that this is the aspect-based sentiment analysis that we have been working for a long time. And this explains the situation. Let's say this is the review of a product, where the product is the laptop. Now, if you do the sentence level sentiment analysis, that you present every sentence and do the sentence level sentiment identifications, then it actually will have an average rating of 3 to 3.5 for this particular document. So you identify the sentiment of these, the sentiment of the second, sentiment of the third, take the average of everything. So average will not be more than that in the scale of 1 to 5. Now, as a buyer, let's say I want to buy a product. I look at this review and the rating is 3.5. Then I may not be very tempted. So it is just above 3, right? But now, if you have the aspect level sentiment analysis, like for example, if you know that price wise, this is a very good product, its zoom is excellent, 5. Because of this, here you can see zoom is excellent. Picture quality is also very good, amazing. Battery is 1.5, battery is very low. And the display quality is 1.0, very low. Now, being a customer, the customer who wants to buy a laptop with good picture quality, good zoom, does not want to pay much, then obviously this product will be of interest for them. But the customers who are actually looking for a product, a laptop with good battery life, with a good display, they will not prefer to buy this product because of this low 1.51, right? So now you see that from the left side of the analysis, that information we are not getting. Even I am a customer who does not want to pay much, want to buy something with good picture quality, good zoom, then I actually should buy this product. And that information I am not getting from the left-hand side analysis, but I can get it from this right analysis, right? Or the battery and display again, they are very low. And if I am a customer who is actually looking for this battery and the display quality, then also I will not buy this product because I'm not very tempted. I'm not getting enough information. If you have this, only the left part is available with me. So this shows that the problem of aspect-based, that is the reason why aspect-based sentiment analysis was conceived, okay, for more informed decisions. And this is a very powerful mechanism, okay, for taking a lot of decisions. Then multitasking and multimodality. So why more than one modality is important? You can see here that if the conversation is going on and the speaker has said that thanks for putting me on hold, I have all the time in the world. Now this thanks is a positive word. Now if you do the analysis of this sentence, because of the presence of the word thanks, the sentiment will be positive. Now, if you say that, okay, but actually the person was not positive. The person, if you look into the context, the person who has spoken this, the person had to wait for a long time and the person was very irritated. And the person has said this, that thanks for putting me on hold, I have all the time in the world. Now from the textual, this description, the model cannot capture this, that the person although has written thanks, but the person was sarcastic, person was negative. How do you identify that? If the person has spoken this, there will be variation in their pitch. The visualizations of that person when the person was writing this, the facial expressions, that actually the eye movement, etc., will help you to know or to get an idea that although the person has said this, but the person was not actually happy, person was really sad. Then I am fine. The second one, again, is a kind of taken from the conversations. Here, the emotion is actually sad, but you see that fine is a positive word. So now, if you only pass this information to the model will give you that the emotion is happy, but actually the emotion is not happier here. The emotion is sad. Because if you look into the context, I have taken this particular attendance from an ongoing conversations. If you look into the ongoing conversation, in the ongoing conversations, you'll find out the person was actually suffering due to a problem. Okay. And while the person was suffering due to the problem, and suddenly his friend was giving some kind of suggestions. And during that, he said that, okay, do not worry, I am fine. Now, although the person has said, I am fine, the person was not in a happier mood. The person was actually a sad. But from this textual description, you cannot identify this. How do you identify this? You can only identify this by capturing the information from different modalities. Now, the idea is that how to capture the information from the video, audio, and also from text. So this is the issue of multitasking, multimodality, and multitasking is another one where you can build an end-to-end model to perform more than one task at the same time. And performing more than one task at the same time is a very important problem of is a kind of problem. If you can solve, let's say, natural language processing or AI problems, multiple related problems, if you can solve by a single system, that actually reduces the complexity. Okay, and this is an interesting phenomenon. The other interesting thing that I told about that how AI can be used in scholarly communication of the peer review systems. Because the peer reviewing that in research particularly, if you submit any research papers, any book for a book proposal, this undergoes the review process. The expert from the domain review it. But it has been found that the review is not always very unbiased. Okay, there has been always bias, and it is true to know that if there are authors now mentioned, and there can be different kind of biases, institutional bias, country-wise bias. So very openly, let's say if something is written from the Western and Eastern, there can be bias. Something from the Southeast Asia, one paper goes from the Western world. Obviously, with the same merit, there may be some kind of bias. So this is true. And this NIPS that is a very well-known machine learning conference, they showed that whatever reviews were submitted as part of this conference, there has been serious inconsistencies among the reviews. Now, how the AI, machine learning, NLP can actually help in this entire process? We actually had done a lot of analysis from the extensive study that we did with more than 7,500 rejected papers. And we try to understand that what is the notion of the important features of a research. For example, the novelty is the important factor, but it is very difficult to quantify novelty. The scope detection is an important. The quality is an important. Okay? So these are all very important problems. Okay? And actually, we have to solve each of them. Now, we actually built this kind of systems where typically the research paper when you submit to a conference or to a journal, this is the typical cycle in the journal that is being followed. You submit the papers, there is the scope. If the paper is outside the scope of the journal, then it is automatically rejected and the information is goes to the authors. If it is, let's say, within the scope, this is forwarded. And the journal has their own plagiarism detection system that actually checks the extensive plagiarism. If there is a plagiarism on that, it is rejected. And if you say that, okay, the extensive plagiarism means what? That word to word matching has not happened. There is no any significant overlap. So it may be forwarded to the next page. Now, in this next phase, what is happening? Next phase, it is happening that there is a specific template. Okay. Some suggestions, sometimes it may happen that maybe the writing quality is not good. Maybe some of the template has a problem. Okay. So that actually goes to the author again with the minor revisions. Otherwise, then it forwarded to the editor. Now editor has a major role to play. By looking at the different papers, the editor has now to decide that who will be the, let's say, associate editor to handle it. Who will be who will be the good, let's say, reviewers to review this particular paper. And this is extremely tedious job because of the volume of submission that is happening these days. If you are involved in a conference sharing, or let's say you are involved in the associate editorship or editorial board in any journal, you will realize that the volume of work that is being given is tremendous amount. Okay. Now, there can be some decisions with the suggestions. It can the editor now find out, assign the particular reviewers to the associate editors. And for that, the expertise is needed. Now, since there is a huge number of submissions, there are all these activities are involved. So there is a kind of necessity that how these efforts can actually be reduced with the help of AI and machine learning and natural language processing, where the AI can help. And the AI can help in this case that to build the systems because you see that if you have a model somewhere here, and when the research paper is submitted, if that engine or the tool can detect whether the paper is structurally following the format of the paper, is there any kind of, let's say, plagiarism, whether that is extrinsic or intrinsic. Intrinsic is more difficult to identify because you might be paraphrasing, you are choosing the words which are actually semantically equivalent. So then capturing those similarity will be more difficult. Okay. Also, is there any novel research involved in the paper? So now how do you identify it is novel research? It is a kind of subjective assessment. Something that is novel to me, it may not be novel to you. So it is a kind of, so giving a kind of objective assessment to the novelty is really hard. Okay. So this novelty will also play a very important role. So if the model is able to identify that, okay, look, this is the paper, this paper does not actually compare with the latest state of the art models. The paper, let's say, has only done an experiment with one benchmark data sets, and more than one benchmark data set it has not done. Then the model has not, the paper has not cited the recent papers. So these are the indicators that the author has been very casual, or the research that is mentioned is not up to the mark or state of the art. So this is a very interesting research that are very important. So we have been also doing let's say that meta review generation is very important. That at the end, as the associate editor, when it takes a decision, he or she actually looks into the individual review. Now, individual review here, he or she has to summarize and make a kind of consolidated kind of summary out of that. So, how to automatically summarize this, generating these meta reviews is actually very important. Okay. So, whole bunch of research we have been doing there. In translation, as I mentioned, is another interesting direction, and there has been a lot of interest, particularly low resource neural machine translations. Can you build a unsupervised multilingual NMT? Uh, if the data is low, NMT is data hungry, SMT, you have the, let's say, phrase pairs. Can you inject those phrase pairs into an NMT models? Can you build it? Now, interactive NMT. So, can you actually get the feedback from the users after the deployment? And can you build the model in this manner? So that means, for example, you build the model, you deploy it, engage the users is giving the feedback, and based on the feedback, you are changing your hypothesis. So this is a research on interactive NMT. That means you are interactive with the end users, you are improving the model's performance. Now, when you actually translate from one language to other language, a lot of information loss can happen. The original sentiment may not be preserved. Original emotion in the source language may not be preserved in the target. A lot of stylistic change can happen. So how can you capture, how can you ensure that even if you do the translation, these changes do not happen? Okay. So it has a lot of application in education because of new education policy in India. All the contents has to be in education domain. Judiciary is very important. E-commerce platforms, they have been doing a lot of initiative to make it more popular so that everything is made available in the vernacular languages. So you see, these are all the system. Even we have our own systems on judiciary domain translations. You can see this demo also. Then e-commerce that I worked with the Flipkart because Flipkart wanted to develop the systems, make their products information, the reviews that are written in the Flipkarts to be made available in the Indian languages. And this happened because of the necessity, because of the COVID, because the e-commerce, the online shopping was extremely popular, has to happen because of this COVID, right? And so there is a necessity from the industrial point of view. How can you reach out to the, let's say, customer in the very rural area? Don't limit yourself only to the urban cities. So if you want to reach to the very rural area, then all the services to be made available in the local languages. Then only it can happen. So Flipkart and we actually had worked on this, translating the product reviews from English to Indian languages. Chatbot also, we did some the multilingual chatbot that can do conversation in different languages like English, Hindi, Bangla, Comics, etc. Uh, there has been other research. I'll talk about that, but today maybe I can take the questions if you have. So any questions so far? Hello. Any questions if you have anybody? Hello. Rakesh, are you there? No questions? Okay, otherwise then you can take a break and then probably you can move to the next one. I'll remain connected. Okay. If there is any question, I can take it later on also. Okay. Okay.
Sir,
Thank you.
sir,
Yeah. Yeah. Please go ahead.
Sir, yesterday your talk was really full of learnings for me, who is a beginner in this field. But today I feel there is a
Mhm.
serious miscommunication because I learned nothing on NER and QA tagging because that was the intended topic, and I don't know what you were talking. That was